Yes, we just started with the implicit differentiation, and I want us to go through it. So we are going through mathematical methods. Topic is actually partial differentiation, and we want to look at implicit differentiation. Very important. Now, when at this value here, f of xy, y is a function of x, and so we want to differentiate that implicitly, and so the whole of this we are saying that we equate it to 0. Now, if that is the case, then we want to use the chain rule. First, let me remind you that f of x is actually differentiable. And because it's differentiable, we want to say that continuity is also assured. And now that that is assured, we are going to use the chain rule in explaining and then computing it. So using the chain rule, we'll have del f del x, dx plus del f del y, dy dx being equal to 0, as I indicated that the whole of this is actually equal to 0. Now, we want to make dy dx the subject. So what we do is that we shall subtract this from both sides. Now, this goes to 1. So when we subtract the whole of this from both sides, because this goes to 1, we shall get the next step. So we shall get the whole of this on this side equal to negative del f del x. Now, once we get that, now from there, we can move on and still do our differentiation on, but because we are making the y dx the subject, then we also get to this important point. Now, at this point, what we are saying is that our dy dx now becomes negative del f del x all over del f del y, and we can simplify it this way. So where this is telling us the differentiation with respect to x, differentiation with respect to y. So the y dx can be expressed this way. So take note of how this is done. You can look at it carefully, the whole of this. So we can say that. Good. Right. So that does it for this aspect. Now let's look at an example. We are saying that find dy dx if x raised to the power 4 plus y raised to the power 4 equals 3xy. So right away we write down our f of x, rearrange this such that the whole of this will be equal to 0. So that gives us our x raised to the power 4 plus y raised to the power 4 minus 3xy equals 0. Now we want to carry out our partial differentiation. So the denominator we differentiate with respect to x. And when we do that, the x raised to the power 4 becomes 4x cubed. The y raised to the power 4 goes to 0. And then we get minus 3y because we differentiate the x. Then the denominator we differentiate with respect to y. So we get 4y cubed and then 3x. Right. Now, that's where we end. Now, remember that the whole of this we have our negative sign there, and so that will be applied to the numerator, and that gives us what we have over here. So that does it for this example. So look at it carefully. Right. So that is that for this example. Very important. All right. So look at it. All right, so I want us to move on to another aspect. So we are saying that we can also write it this way. So we can also get del z del x, and we can express it as negative fz over fx. And then del z del y, negative fy fz. So we'll do the partial differentiation that way. Let's try to apply to this question. So example, find del z del x and del z del y if x cubed plus y cubed plus z cubed plus 9xyz equals 3. And so we go through the same motions in trying to answer this. And so our del z del x gives us this. And then we take our time and do the partial differentiation. So for our differentiation, partial differentiation with respect to x, we get 3x squared. From here we get 3x squared. This goes to 0. 0, and then the 9, we get 9yz, because when we differentiate the x, we get 1. And so that gives us the numerator. For the denominator, we are differentiating respect to z. So we get 3z squared, and then over here we get 9yz. All right. All right. So look at it. So we get 9xy rather. Now we can also simplify it again. Remember 9 and 3. So when we do that, that takes us here. So we reduce it to its lowest terms. Okay, so we get it this way. So from, you divide through by 3, and that takes us there. So we have this. All right. Now, in the same vein, we now want to look at our del z del y. And so that can be written as negative fy fz. So the numerator, we differentiate respect to y. So from here, we shall get 3y squared plus 9xz over here, because we differentiate respect to y. Then the denominator, because we are concentrating on the z, so we get 3z squared plus over here 9xy. And in the same vein as we did with the previous one, we divide through by 3. So we shall get neg y squared plus our 3xz, and then all over z squared plus 3xy. Okay, so that does it for this aspect. Now we want to look at this assignment. So we are saying that use the chain rule to find